All right, this will be the last video I make here for chapter 6. There's just a couple of things I wanted to talk about real quick before we jump into a harder question, and that's some definitions. You may see something called a centroid. If you ever see the word centroid, that's still talking about the center of mass, but this is going to be the center of mass whenever your density is just set equal to 1. So basically, it's the center of mass if you have a constant density for your object. So just if you ever see the word centroid, still means center of mass, but you're just going to be setting that density equal to 1. All right, so we're going to jump into a question here, and I think I want to do this question number 22 here in the book. So this is in the back of the section. Usually I do problems in the section itself, but we're going to try ourselves here. So find the center of mass of a thin plate covering the region bounded below by the parabola y equals x squared and above by the line y equals x if the plate's density at the point xy is delta of x is 12x. So this time we don't have a constant density, we're going to have a varying density here. Okay, so it's y equals x squared and y equals x. Let's go ahead and graph those two things, see what they look like. Y equals x squared is going to be the normal parabola. Y equals x is going to be the diagonal line. So it looks like we're talking about this region here in between them. All right, remember the other stuff that they gave us was that the density is a function. It's the function 12x. Let me just double check, make sure that looks right. Yeah, okay. And I think that's all we need. So the next thing that you needed to do is you need to decide whether you want to do horizontal slices or vertical slices. It looks like for this question, it really doesn't matter because vertical slices are going to be going from the parabola up to the diagonal line. So that's a nice, easy definition the entire way. And then horizontal slices would be doing the same thing. Horizontal slices would be going from the diagonal line to the parabola. It's just kind of preference at this point, whether you want to be integrating with respect to x or integrating with respect to y. I'm just going to do vertical slices here. Actually, no, now that I think about it, I think we're going to have to do vertical slices for this question, only because they give us the density as a function of x, which means that as we move along the x-axis, each of my slices are constant for each of the different x values. But if I did try to do horizontal slices, the density of each of the slices would be changing. So I guess that is kind of a giveaway. If they give you that the density is a function of x, you have to do vertical slices here. All right, with these vertical slices, remember the next thing we want is to find the dm, the x wiggle of each of the slices, and then the y wiggle of each of the slices. The dm is the mass of each slice. If my slices are vertical, that means each slice is located at x. I would need to know what this intercept point is here. I'm pretty sure it's 1. All right, if I plug 1 into the equation y equals x, I get 1. If I plug 1 into the equation y equals x squared, I also get 1. Okay. Then the dm is just the density times the area of the slice. But now my density is not constant. Now my density is going to be the function 12x. My area is length times width of my slice, where the length is going to be the difference between the straight line and the parabola. Be careful of the order here. The straight line is above the parabola, which means that that's the furthest distance. So you have to take the equation of the line minus the equation of the parabola to get the length of the slice. That times the width of the slice, but the width of the slice is that infinitesimally small distance dx. We can simplify this down a little bit by distributing the 12x into there, and we get 12x squared minus 12x cubed dx. Ran out of room there. Okay, the x wiggle. So if we were to look at each of the slices' center of mass, because the slice has a constant center of mass for that given x value, the slice is going to be the halfway point. The x coordinate of the center of mass of my slice is just going to be located at x, since that's where my slice is located on the x-axis. But the y coordinate of the center of mass, about there, that is going to be the halfway point between the top value and the bottom value. And you want to think of it like an average value. To find the average value, we're going to add these two things together and then divide by 2. So that's going to be taking the top thing, x, plus the bottom thing, x squared, adding those and dividing by 2. We can simplify this down by just dividing each of these by 2 to be 1/2 x plus 1/2 x squared. All right, and now that we have that stuff, we can find the total mass. That's just integrating over dm. For us, that's going to be the integral from 0 to 1, since that's where my slices exist on the x-axis here, of the dm, which was this 12x squared minus 12x cubed dx. Antiderivative, this 12x squared is going to go to 4x cubed, minus this is going to go to 3x to the 4th, that evaluated from 0 to 1. If I plug 1 into this, I get 4, minus 1 into this, I get 3. The 0 doesn't do anything. Looks like I have a total mass of 1. Okay? The moment about the y-axis, that is going to be the integral, again from 0 to 1. I guess I should write the definition, right? So the moment about the y-axis is the integral of x wiggle dm, that's from the formula. So the integral from 0 to 1, x wiggle is just x times dm was the 12x squared minus 12x cubed dx. Distributing the x into there, we get 12x cubed minus 12x to the 4th. This has antiderivative. This is going to give us a 3x to the 4th, minus this is going to give us a 12/5 x to the 5th. That's from 0 to 1. If I plug 1 into this, I get 3. Minus 1 into this, I just get that coefficient 12/5. The 0 does nothing. 3 minus 12/5 is, I don't know, something. So let's think about it. That would be 15/5, so 3/5. Okay, great. I do want to talk a little bit physics-wise. Because this came out to be a positive number, that means when we are looking about the moment about the y-axis, it's going to be rotating like around the y-axis in a clockwise fashion. If you were to look down the y-axis, it would be going around it clockwise. Or maybe I have those backwards. It doesn't matter, but I think positive is counterclockwise, negative would be clockwise. That makes more sense. Okay, moment about the x-axis. That's going to be the integral of y wiggle dm. This is going to be our bad one. Still the integral from 0 to 1. Y wiggle was this awful looking thing, 1/2 x plus 1/2 x squared. dm, remember, was this awful looking thing, the 12x squared minus the 12x cubed, and then all of that dx. So we're going to have to distribute, or not distribute, FOIL these things together. 1/2 x times 12x squared is going to be 6x cubed. 1/2 x and 12x cubed is negative 6x to the 4th. 1/2 x squared and 12x squared is positive 6x to the 4th. Then 1/2 x squared and negative 12x cubed is negative 6x to the 5th. My 6x to the 4ths cancel out, so we just end up with the integral from 0 to 1. 6x cubed minus 6x to the 5th. Antiderivatives now. This 3 is going to raise up to 4 and we'll divide. 6 divided by 4 is 3/2. Here the 5 is going to raise up to 6 and divide, which will cancel out with that 6 in the front. So that's just x to the 6th. This is from 0 to 1. If I plug 1 in here, I'm just going to get the coefficient 3/2. Plugging 1 into here, we'll get the coefficient 1. Plugging 0 in does nothing. 3/2 minus 1 is just 1/2. Okay, now that we've done all that, now we can find my x bar, y bar. X bar is the moment about the y-axis over the total mass. The moment about the y-axis we found to be 3/5. So that's going to be 3/5 divided by the total mass, which was just 1, so we get 3/5. Y bar is going to be the moment about the y-axis over the total mass. That came out to be 1/2. That's going to be 1/2 divided by the total mass 1, so just 1/2. Which means that the center of mass of my object here is at the location 3/5, 1/2. So if this is 1/3 would be, I guess, right about where I have the x value, which means that if that's 1, this is at about 1/2. So this location here would be the center of mass. Always kind of double check and go back and make sure that it makes sense, right? You want your center of mass to kind of be in the middle of the object where you would expect the balance point to be for your system or for your area. Okay, great.